So we've already taken care of the detection of the player. So we have our alerted Boolean variable set to true if the onTrigger enter is is called when the player's collider's rigid body enters the turret's trigger collider. So now you can get the sense that we'd like to use the alerted variable for something. So let's have a look. Let's set it up like this. At the beginning of the update function, if alerted, yeah, let's use our interpolation trick again. I'm using the lerp function again, which comes from the mathf library. This is a collection of common math functions, again using floats usually. So again, let's have a quick look. By the time I do it a few times, hopefully it will kind of stay put in your memory. Eventually this is a very useful one that in a lot of situations. So lerp, linear interpolation, has three arguments here: float A, float B, and float T. What we'd like to go is return a value between A and B, depending on the value of T, and T here needs to be something between 0 and 1. So we'd like to go between our current version value of interpolator and 1. So this is because we've alerted the turret. We'd like this interpolator to start moving toward 1. Whatever value we started with, 0 or 1, we'd like to interpolate between the current value and 1. And T is going to be some arbitrary value that perhaps we can expose just to see how fast this goes. That's maybe a good idea. Let's add another public variable. Turret speed, because effectively this will define how fast the turret will move toward the player. Let's start with a value 0.1/10, which is going to be probably quite a lot. Now this is going to be frame rate dependent, so let's just go 0.1. I think that's going to be a bit too fast, but let's see. So if alerted, then this interpolator needs to start moving toward 1. If in the other case, so else, we do something very similar, only our end value is 0. Okay, just let me see. Maybe I can bring up some nice example again. Let's see. Okay, so like this is an example. For the lerp function again, just to make it really clear in your mind what we're dealing with. So this is our T value, the third parameter, third argument to the function. So if 0, then we go from value 1, which is in this case 0, 0. This is for vectors, so this is for like a two-dimensional position, for example. We'd like to go from this point to this point. So for t0 we're gonna start with 0, 0. For t1 we're gonna end up with 1, 1. And for t somewhere in the middle, like half, we're gonna end up with a value in between. So yeah, LARPing works for vectors too, like this will be the vector 2 LARP function. We are dealing with a linear interpolation just on a float value, so we just have a simple float value a and b and our turret speed. Because this is happening every keyframe, every update, this will result in a kind of a smooth animation toward the final value. So, okay, let's test that. Well, that worked right away. So that was easy. And this is how fast the turret is now reacting. Okay, this trail is getting in the way, but for value 0.1, now it might look a little bit different on your machine depending on the frame rate again. Let's change it to something like 100th. So I'm going into the inspector now and I'm going to change it to a 10 times smaller value. On the fly, okay, we can see that the turret is now much less responsive. We can personalize. Yep. Okay, how did that happen? Thank you. Okay, so let me show you again in case that wasn't visible. So I've changed the value here on turret speed to 100th and and now we have a slow rotation. If I make it 1, what is going to happen? It's going to be very, very reactive. So it's going to just go straight to the target value without messing around. So somewhere in between, half, that's going to be still, you can kind of get an idea. It's just going to have a very rough interpolation and only a couple of steps, so we definitely want something less than that. So actually that 0.1 value is quite fine. Let's personalize it, let's make it a little bit more creative, and let's create actually 2 versions of this. So let's create turret speed on and turret speed off. And let's have 2 values. So let's say on default value we're gonna make it 0.1, and off we're gonna make it half of that. So this will make our turret. Okay, and let's use it in code. So now I have, these were now highlighted because I've just deleted that variable effectively and created different named ones. So if alerted, I want to use the turret speed on interpolation and off in case we disable the turret. So let's try. Okay, so we have a. It's not super distinct. Let's make it even faster there. Let's give it 0.2 for on and 0.025 for disabling. Please shout if I'm going too fast between the Visual Studio and the screen. Yeah, I just wanted to make it a little bit more expressive, so it's not necessarily speed that you need to be thinking of. Okay, there's this, okay, 0. Because I already have a value assigned in the inspector, this is the value that's going to be used, so I need to override this in the inspector now. If this was the first time that you added this component to the script, then it would be fine, but in this case changing the value in the script is not going to modify. Okay, I also need to stop execution, so let's go for this. It's basically a simple technique of animation. What we end up here is a kind of a smooth curve. Because it's a geometric, it's kind of a geometric sequence that leads and converges onto the value, the final value. It's a smooth, it's a smooth incrementation which actually decreases the closer you get to the final value. So this is what generally is referred to as smoothing. In video editing programs or using animation in Unity, those kind of smoothing envelopes are used a lot. Otherwise you just have very kind of jerky movements. Okay, so I think that's okay. Okay. It would be nice to add a little bit of sound variation as well when we trigger this movement, whatever. Okay. So, we're getting there, but I think now we need to think about the actual bullets we want to shoot. So let's get busy with that. Let's create a new game object. Let's create something like a sphere just by default. I just created a 3D object here. Like I'm sure you've done this, but right click, game object, 3D object, sphere. Creates a kind of a default combo of a sphere with a default material and a sphere collider. I'd like this to be also trigger, and I'd like the radius to be smaller than this. So let's see. This shows me the size of it. That's too large for a bullet. So actually, the best way is to change it here in scale. This will affect the whole of it. So let's make it 1/10. So that's a small enough bullet, and let's make a material for it. So I'll go to the materials folder. I'll go to the materials folder and create a new material. That's a little bit of a detour, but well, let's learn a couple of useful things along the way. So let's call it bullet. And okay, what do we want for a bullet? We want something that's definitely very visible and kind of high contrast against the environment in any lighting conditions. So whether we're in the shadow or in the light, do we want? Well, let's make it kind of an energy bullet. So let's give it a color, albedo color, like an orange. Let's see. Quick question to you. What kind of property of a material do we use if we want to be independent of the existing scene lighting? Come on, that's to the artist in group.
Well, if you want to and complexity, you go for more metallic.
Yeah, fair enough, but that's still going to be dependent, because imagine a scene with no light in at all. What's going to happen? Are we going to see our bullets? Whether you use metallic, smooth, whatever albedo color you're going to use, if there's no light, we can actually make that experiment here. So we've got our Yeah, exactly. So I'm gonna switch off the city light just for an example right now. Okay, and there's also ambient in the scene, so maybe that's not a great demonstration, but yeah, okay, what you're looking for is emissive. So emission, okay, I've already oh, that's okay, I already had a bullet material in there. So emission in the standard material is basically a color that gets added onto the material regardless of what illumination is there in scene. So it could be a map, it could be a texture, but in this case we're just gonna go for, like, let's say, yeah, something like this, and albedo in this case. You see, the albedo doesn't really matter very much if our emission color is a high value. Like, I can remove it, so now I'm going from 0 to full emission color, and let's keep it at something like this. We cannot really see the bullet now, so okay, let's see. Okay. That's our sphere. Let's name it bullet. And let's add the bullet material to it. Okay, so now our bullet is illuminated. You can see it here. Okay, that should do it. I think maybe the bullet is still a little bit large, so I'm just gonna bring it down to 0.75 on all axes. Right? Okay. Since I'm working on creating a prefab, I am going to reset the position to 0. I don't see it, but that's too bad. Alright. And now we also will need to create a script for it. So let's go for it. Bullet. Create an app. We don't need this, we don't need this anymore, we don't need this, okay. Okay, so very simple bullet class that does nothing. So, first of all, a trick. Like, let's say we want our bullets, we want to shoot a lot of them, and we don't want to overload our machines, so we have to have some kind of a capping mechanism to limit the amount of bullets in scene. Probably the easiest way is to use the destroy function. So, IntelliSense is showing me overloads for the destroy function, and the second is now one which takes the float t. What is the t? The t is actually time. I think I might have mentioned this to you already, but let's go with this game object. I'm doing this like this because just this, if I left it like this would destroy the component, not the actual object. I need to destroy the game object. Let's give it time of 7 seconds. 7. Depends on how fast our bullets are going to be flying. Let's go with 5. Let's go with 5, a float value of 5. So this will actually destroy the object after a time interval of 5 seconds. So we won't have to worry about too many bullets staying in the scene. So yeah, that's a range after which our energy bullet just disappears. So okay. Let's make some decisions. So do we want the turret controller to actually assign the direction of the bullet itself, or do we want the bullet to be smart and know where to fly? That's kind of up to you, depending what you want to, where you want to go with this further on with the game. But let's go with a kind of a simple approach that the turret controller is just gonna instantiate the bullet prefab, and the bullet will just wake up, determine where the player is and the initial speed of travel, and then just keep moving in that direction. So simple enough. Going back to our turret controller, well, okay, let's leave it for now. So we will need to do something in start other than defining the destroy time. We will need a target again. So okay, any suggestions from you? What variable would we need to work with this? What would be handy to have as a private variable? A vector, yes. So I'm gonna, yeah, this is fine, aimVec, we can call it aimVec, and we're gonna initialize it in the beginning. So again, aimVec, and since we've just done a very similar thing in the turret controller, I'm gonna save myself some typing. Okay, obviously this pops up a lot of errors because I don't have the gun transform position and so on. We don't need the gun transform in this case. Our start position is our bullet position, so hopefully the turret will at least do the job of instantiating the bullet in its starting position, so we can do that. So this is okay. Our starting point is transform position, and the end target is again look target or aim target. So maybe call it like that. And we need to take care of that again. So what is aim target? Let's create this public variable again. Doesn't actually make sense in this case to have it public, because in this case the aim target is a player object which is outside of the bullet prefab. It is going to be outside of the bullet prefab, so we won't be able to assign it by hand anyway. So I'm going to make it private, and I'm just going to copy this code. I don't even need to check for this, but let's go ahead with it. Okay, aim target. Sorry. Well, at the risk of making it somewhat not foolproof, I'm just gonna leave it like this. I'm just gonna find the object with the player tag and transform, and this opens us up to some problems down the line, maybe if there is no player object in the scene, but well, hell. So I have our aim target. I found it using the tag and aimVec. Sorry. Okay, I'll leave this maybe so that you have a chance to copy. It is, by the way, nice to type the code yourself or copy it as you go along. But if you find it too difficult, yes, you can load the final version of the scene and just follow up. So maybe some of you are doing that, which is fine. I think you probably get higher retention if you do it like if you use muscle memory and actually go through typing and running into some errors. I know it's a kind of a maybe tough call if I'm going too fast, but I'm open to feedback about how we're doing this. This is a new format for me also, so any info that helps it to make it easier to understand, let me know. Okay, so what do we have? Now we have a vector. Do we care about the magnitude of this vector? Should the bullet be moving faster if we start with a large vector versus a small vector? When would we have a large vector? A large vector when the player is very far away from the turret, right? And a small vector.
I would presume within a small area the bullet would be slower compared to a long area, so that it gives a chance for the enemy to be challenging to the player instead of a long distance and a slow bullet moving.
Yeah, well, okay. If that's what you want to do in your game, sure. Yeah. So that would be kind of a way to do it if that's what you wanted. Like in this case, let's say that I want the bullets just to be fired at the same speed all the time. So we haven't done anything with the position of the bullets. So let's maybe move to update. We won't be using physics for this. I decided, just to make things easier to follow in this case, I decided just to move the transform the usual way, and there is no rigid body on the bullet. So these bullets won't interact with the buildings or the player per se. They were just used to detect if it hit us. So okay. So in update, transform position and plus equals, let's say aim vec times, we want to somehow be able to control the speed of the bullets, so I'm going to add a public variable, float speed equal 0.1 maybe. Actually, let's go for 10, and so we will add a certain small vector to the current position of the bullet. So again, we're using the increment operator here. So it's incrementation and then assignment, and we're dealing with vectors, remember, so this is all C# is smart enough to overload all those operators depending on the type it uses. So so we add aimVec times speed. We can multiply a vector by a float value, you remember. So this is a float, this is a vector 3. If we multiply it by a fractional value, we'll have a shorter vector. But we also need something else. Any ideas? We don't want our game to be super dependent on what frame rate you get. So we do need to use our time delta time. Alright, so let's try what that does. That won't do anything. I've forgotten something. We haven't modified our turret class at all. We haven't created the prefab yet. So let's say maybe this is a good time to make our prefab bullet. Okay, and I'll go to the prefabs folder and drag the whole lot there. Okay. Right. Okay, now I can remove this from the scene. Obviously the turret needs to use that, so I go to my turret controller. Okay, and make a public game object. Bullet prefab. Okay, and we'll assign that. This is an asset. This is going to be an asset. A prefab is an asset, so we're perfectly happy to. It is. Okay. So this is the prefab. And I'll use the bullet prefab here. So we can actually assign this straight in the prefab. Yeah. And let's do something with it now. When do we instantiate it? Let's say, let's do it in a simple manner at this stage. Remember, we have our interpolator variable, which goes from like 0 to 1, depending on whether the card is active or not. Let's say if interpolator, so this is kind of interpolator is our tart activation thing, like as it tells us how close the tart is to pointing at the player. So let's say if the interpolator is larger than 0.9 float, we'll instantiate our bullet prefab, and we'd like to set up the position. So let's let's instantiate it at the gun form position, gun transform position, and we need a rotation. Okay, and that actually should be okay. Yeah. So I've instantiated the bullet prefab using the center of the gun model. And 0 rotation, and that happens when the gun nozzle is almost pointing at the player. So we will have something of a kind of a realistic physical effect or whatever. We'll give it a chance. Let's see what happens. So this is our simple approach at the shooting mechanic. Okay, let's see. Okay, so it is working. The bullets are flying right through us though, which is something we need to take care of now. So what are we going to use for this? First of all, I'll go to my bullet prefab. Open prefab. That speed, I didn't like that speed. That was a bit too fast. Let's make it 4. Alright. Okay, and we want to use a trigger again. Remember that the bullet was set up as a trigger, the collider on the bullet. So I'm going to go into the bullet class again. On trigger, enter. Actually, even lazier, I'm just gonna copy all this and paste it from the tart controller. So but we do something else in this case. So if the trigger enters, I don't care about exit, I just want the first trigger enter. Going back to our theory here, like, okay, so trigger enter happens when the rigid body of the first object enters the trigger area. On trigger exit is called once In this case, like enter is called once when the rigid body first enters. Exit called once when the other collider has stopped touching the trigger and was touching it before. And on trigger stay is going to be called for all the frames where every collider other that is touching the trigger. The function is on the physics timer, so that might be running at a different frequency than the rendering frame rate, so be aware of that. It's tied to the physics, not the rendering. So what are we gonna do? Well, we're gonna do two things. So in this case I have to extend my little code a little bit more, so I'm gonna use brackets to have a kind of more compound instruction block. So yeah, let's say I'm gonna just do it very simply, debug log. I'm gonna print hit into the console. Not very exciting, but just to prove it's working. Okay. Thank you. Alright, so when that happens also we want to destroy. Destroy the bullet. Okay, so let's see what that does. Okay, we can see that at least some of the bullets are stopped by the player. Or are they? Let's see. Yeah, definitely hit is being spammed to the console. Now the reason why not all bullets are being stopped by the player is that remember that we are using this very simple position update where we just increment by a certain value depending on the time and depending on the frame rate. So maybe that bullet is actually at one position is before the player not touching it, at the second frame or physical frame rate it is already behind the player, so there will never be a collision. So to fix that we'll have to kind of play more with the speed of the bullet, or maybe have a larger collider or a separate collider for the for the player that just deals with the bullets. Anyway, we're doing things kind of like the simplest possible way, so yeah, it won't be perfect. Maybe I'm gonna just change that speed down a little bit more. Okay, let's make it 2. Maybe that's more reasonable. Yeah, that seems to stop at least. Yeah, okay, so now the bullets are being stopped when they actually hit. Okay. Alright, one thing, it's actually not very healthy to spam the console like this for performance reasons, especially in editor, so I'm just gonna comment this, right? // and this bit of code becomes a comment, so it's no longer used. Okay. Alright, but this is this approach has problems because the bullets are gonna be sent toward the player whether there's a building in between the turret or not. See that we're starting to get, so in this case like we're getting something we probably don't want. So we need to extend our toolbox of Unity tricks and talk about raycasting. So Okay, so a raycast is basically a directed ray with a start point and maybe an end point or maybe infinite, going in a certain direction. So a ray has a direction. Raycasting is governed by the physics engine, so raycast is actually a method of in the physics namespace. It requires us to provide the origin, the starting point, the direction, and it will let us get some information back. We can specify a maximum distance that we want to use. So for example, some cases we don't care. We know our bullets are not going to reach too far, so we only raycast to a certain maximum distance. And then we use layer masks. So layers. Anyone used layers before in Unity? To a certain degree, they are a bit like tags. They allow us to group objects together and make logical kind of groupings of them. Think Photoshop layers. That's not that much different in this case. There's some default layers. So in Unity, layers 0 to 7 are already predefined, and they're used for some specific cases. But from layer 8 upward to 31, we can create new ones. So let's create a couple of layers. Just to make it clear, okay, go to inspector on any objects at all, pull down the layer, pull down, add layer, and let's add a few. Let's add a player, let's add machinery, so that's going to be our turret. Let's add buildings, and let's add bullets. Okay. Alright, and save the project. So that actually, if you look in what's happening now in source tree or your Git client, which shows you what files are being changed, just to get you an idea. Tag manager asset now been changed. So this is where this is hiding. In project settings, in your project, there's a tag manager asset, which is basically a simple text file, and it holds your layers. You see that there are 4 lines added: player, machine, buildings, and bullets. And remember, at the beginning of the lecture, I have I've told you to exit Unity between changing branches. So like this might be one of the cases where it pays off to exit Unity before you do something externally with the Git client. Because if you have currently a scene open, it might not update the tag manager asset properly, and you might run into problems of, for example, some objects referring to a layer that's not defined. So let's assign those layers. So player, this is already assigned. I already did it before. But if you do it from scratch, yes, change children, yes, I want all the objects underneath player to have that layer. The hostile turret layer, let's make it machinery, yep. The hostile block in this case is the buildings in our scene. I just modified them again, and let's change the layer to buildings. And the bullet itself, let's assign it to the layer bullets. So what's happening with these layers? Why would we need them? So they're used for rendering, and they're used for physics. So for rendering, camera culling masks. I'll show you something fun now. let's run the game and select our main camera, and let's go to our culling mask for the camera. This allows us to select which layers the camera is actually rendering. So I can disable machinery, and voila, the turret is no longer there. You can do some interesting things, like for example, okay, I'm going to do something a little bit strange. I'm going to duplicate the main camera just to show you, maybe give you some understanding. I'm going to remove the simple camera follow. So now I have two cameras in the scene. Okay. The camera that is following the player is now not being shown, and that's why. That's because the depth. Okay, if we have more than one camera in your scene, so in this case main camera 1, then the order in which they are drawn is defined by this depth field. So -1 is going to be lesser priority than 1, or even 0. So what's happening now? Okay, I see the camera which is following. What happens if I change the clear flags here? Okay, let's do don't clear. Now I have something really weird happening. I actually have two cameras overlapping in scene because I didn't clear the flags. So it is our Z buffer. Well, I mean, this is maybe a bit more too technical, but kind of like a kind of effect that you can use, actually quite useful for something like drawing UIs. Lets you separate the UI layer, the interface layer, from the actual game stuff, and you can maybe have different properties of the camera. It can be very, very useful for example, for the interface you can have a different clipping plane settings, maybe different rendering settings. Okay, after stopping playback, obviously everything came back to normal, which is what I wanted. I don't want this double camera setup. But this was just to show you that cameras use culling masks, and that uses the layers that we just defined. So probably you want everything set up on your culling mask. This means that the camera renders everything. You can also select nothing, and then your game shows you nothing. Great. But to get to the point, layers are also used for physics. So raycasting. This is the raycast function. It returns a Boolean value whether we hit something along the raycast ray or not. So if it actually means whether the ray intersects with a collider, right? And you may provide a layer mask to filter out any colliders you aren't interested in generating collisions with. So, okay, this is a bit of sample code, so I'm just going to copy that here. Please. And I'm going to add it into the turret controller. So I want to change this bit of code, which here it only starts shooting when the interpolator is equal larger than 0.9. I don't want that mechanic to be in place anymore. I want to work with raycasting. So I'm just going to paste this bit of code there. First you define a variable of type raycast hit. This will be a result of a hit. And okay, in physics raycast, we start with transform position. Is this the right position? No, we want the center of the gun again. So gun transform position, transform direction. We already should have. Okay, our aim vector, we've already got that. So we've already got the direction for our raycast. Only we're using it somewhere later in the code. So I'm just gonna grab this bit of code and drag it, or Control-C, Control-Z. Okay, I'm gonna do it at the beginning of the update. So now the aim vec, I can already use it here. Or actually, just occurred to me now. I don't need to do it this way. I can also use the gun transform forward direction. Maybe that's a better way to do it. Either or, more ways than one to skin a cat. Note this out here. This means that this argument here is going to be a variable which is going to be assigned a certain value. Now this infinity here. Okay, let me look here. Origin, direction, max distance, layer mask, query trigger interaction. Okay, so that's not this. So this is the maximum distance. Let's say I'll leave it at math f infinity. This means that I'm shooting the ray out into the infinity. Whatever is anywhere in our game world, no matter how far, the raycast is gonna pick it up if it's along that line. And layer mask. Okay, so I would like to only do this for certain layers. I'm not interested in raycasting with the turret itself. For example, that would be a problem if we shoot from the middle of the gun object and we hit itself. That wouldn't really help us. So I'm gonna add a public layer mask, raycast mask. Okay. What this will do, okay, right now my code is actually, okay, layer mask, raycast mask. Okay, I need to rename that. So this should compile. Okay, it's not doing anything, but that's maybe because we haven't finished this part yet. Let's go to hostile turret and our raycast mask. Here you can select whichever one you're interested in. So I'm interested in the player. I'm also interested in buildings. I click these two and now they accumulate, so I can have a mixed mask. This means that our raycasting will only take into account the player, layer, and the buildings. Because, why? Because I want the first object to be hit to stop the raycast going further in case the player is behind the building. Okay, that makes sense. So we will do our bullet instantiation the same way we did before. However, do we want it to be? Do we want to shoot out the bullet if the raycast returns a building? No. So how do we do this? We have our hit variable, which this function will actually assign something to. This is going to be the object that we hit with our raycast. So hit, and let's see what we can access. I'm typing the magical dot here, and collider, normal to string transform, blah blah blah. I think collider is the one to go. Collider, and what's on the collider? Tag. Okay, so we're home. We know what to do with this. So if this is a logical condition, so whatever is in the brackets here needs to return a Boolean value, true or false. So if the tag is equal to player, then we want to do whatever this if contains. So we're good. Let's run this. Okay, so yeah, good. Let's hide. Okay, so we got something that starts to make sense. Our raycast is working. Another thing I'd like to show you in regard of the layers is something that helps you optimize your games a little bit. So let's go to project settings, physics. Here is something called the layer collision matrix. So here we can specify which objects collide with each other, and this is done. It's a half of a square array because obviously this goes both ways. If we don't want the player to collide with the bullets, then we don't want the bullets to collide with the player. So that's why there's only like a triangle here. So let's try that. Let's make player, let's disable player colliding with machinery. Let's look for player here. Let's look for machinery in the column and disable that and see what that does in our game. Oh, and now we can fly through the turret now, so this is what this is for. I've re-enabled it, and now everything is happening like it should. Again, the actual dome doesn't have a proper collider, but this, okay. Yeah, so you can see that it collides again. Why would you want to use this? Well, physics are expensive. So if you can tell Unity that certain layers don't have anything to do with each other, you don't care about the physics between them colliding or not. For example, you might have some physics even in your UI, and you don't want them to interact with anything else, then you would leave it something like this. You would just let UI layer objects interacting with each other, but nothing else. Okay, in this case you'd have to do this. So this kind of setting means that only UI objects are calculated against other UI objects. So let's re-enable this. I think that's... Yep. Good point, thank you. Well, like I said, it's just getting used to the format. So, okay, so what I was showing is that if I want to say the UI objects, I don't have any in the scene, but let's suppose that I have. And usually you maybe wouldn't want to use physics with it, but let's suppose you do. Good. So this kind of settings tells Unity Physics to only calculate collisions and raycasts or whatever between UI objects and other UI objects. They wouldn't interact with anything else on any other layer. Okay. Okay, so what else is problematic? Well, maybe we're shooting too many bullets, possibly. We'd want to control that. What would be like the simplest way to do it without going into too much complexity in our bullet object class? Well, a quick and dirty way to do it, just use a timer. So let's try that. Oh, before I go further, any questions about this particular bit, or is everybody able to follow? Okay. Okay, I'll give you a second to catch up. By the way, all this is covered also in that already previously assigned section in Harrison book. So working with Unity physics to colliders and collisions, you would have slightly different samples of this and also different bits of code. So it's definitely worthwhile to go through those examples there. Okay, let's go back to our bullet class again. Actually, pardon me, let's go back to our turret controller. I set a timer. Okay, let's add a timer. So private float gun timer, and default value. Let's decide on our starting value. Well, no, actually, let's make it 0. I'll explain why. And public float gun interval. So this is going to be the value which we can assign in the inspector and decide how often our gun is shooting. So let's start with, say, every second. Okay. So we'll be able to change it at runtime. So the simplest possible way to approach it, and you'll be doing this kind of thing potentially a lot of the time. In update function, it's a little bit hacky, but it works. So gun timer minus equals time dot delta time. So every time we render a frame, we decrement our timer by that by the time taken since the last frame. So this is a kind of a very rudimentary counter. And what do we do with this? Now, if our physics raycast is successful, if hit collider tags is equal player, and that will add additional and if gun timer is less than 0. So what's gonna happen is we're always decrementing the timer. We allow the turret to shoot when that value is less than 0, and immediately after shooting we reset the gun timer to the gun interval value. Okay. So this actually should take care of it. Why less than 0? Well, we could set it up in a different way, but I figure, okay, we start from this value of 1, decrement it, it goes down, 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 down. When it goes down to 0 and below, we can allow the turret to start shooting again. Okay. Okay, so every single second now. Gun interval, let's change it. So now it's customizable. And maybe we could tie it into some other thing in our game, depending on the distance to us or whatever else we like. But that's a simple way to do it. Let's leave it at maybe 2. Yeah. Alright, so let's have a little review. So what we have done. We've extended our turret prefab with a sphere collider, set it up as trigger. This is a zone. We added a controller script to the turret with callbacks on trigger enter, on trigger exit, that modify our flag, alerted, and we use that flag to change our interpolator. We can actually remove this code, but let's delete this. We don't need it anymore. And we've created a bullet class, which is also using the callbacks of onTriggerEnter to destroy the bullet object and maybe do something else like trigger audio. Well, we have a little bit more time, so maybe let's add a little bit of audio. Let me see. I will need a wave for this, so I didn't add a specific asset to the project, so bear with me. This is something I can add to the actual turret. So one thing to remember while using sound is that you have to have an audio listener on the object. That's added by default. Once that's there, you're good to go. So audio source, and an audio clip. Okay, I don't have anything, so I'm just gonna quickly drop some wave file into the project. Let's see. I found some OGG file, yeah, that has a very very basic clicking sound, so I'm going to drop it into the project. Bam. Okay, that was imported. Now I can select it. Okay. Do I want it playing on awake? No. Do I want it looping? No. I want to trigger it from code, and this is what I'm going to do now. Start controller. I'll do all these things, but also let me do it in a quick way as well. Private audio source, variable on start. I'm gonna just just find the corresponding component of the type audio source. This is how you might want to do this. Alright. And all that remains to be done is here in update when we shoot. Play. Okay, and let's see. You might, okay, I'm using headphones, but that's really the crappiest shooting sound ever, but it demonstrates the idea. Okay, we have a few more minutes. We went without a break, so we'll finish a little bit earlier. Open to questions. Anything along the line that caught your interest specifically or was specifically difficult? Come on, everybody asleep? Just a second.
There isn't any
okay, well, yeah, we both. We set up the callback on trigger enter on the bullet object, and you see this is the argument for that function, but you don't call that function yourself. This is Unity calls this when it detects the collision. So some other piece of code somewhere else detects the collision and runs this method with that argument of what it found to be colliding with bullet. So now here I'm querying that collider, finding its tag. If it's the player, then I destroy this object. Does that make it clear? Well, that's up to you. Like this is the way I decided to do it. I wanted to put this logic onto the bullet, but you could do it, and maybe it would make more sense from your point of view, is to have this type of code created on the player and use the bullet layer, for example. Because here, for example, We can try that, actually, that's maybe a good point. I'm going to disable this code on the bullet. This is how you comment out a larger section of code. /*, and I'm going to go on to our player controller. And if you look at the slides, the on-trigger enter is going to be triggered under these conditions. So actually the player has the rigid body, the bullet has the collider trigger. So in this case, let's see, on-trigger enter, collider other, and now we need to make sure that we don't collide with something else. So we want to be using the tags. Okay. Let's use the layer. Hopefully I can do that. It could be the name that I'm using. There's many ways to do it, but maybe I'm just gonna go with game object layer. The layer is an integer actually. So if you have a look, that's actually good that we went into this. If you look into the layer listing. If you click add layer, you can see the numbers for each layer. So in this case, layer 11 is our bullet. So if other object layer is 11, then we do something else. Then we can destroy that object. So other game object destroy. So we're doing it the other way around. Okay, yeah, maybe that's it, but we have to do it. Yep, and, well, let's do something else. Let's put an audio source on the player as well. Okay. Add audio source. Okay. Play on awake, we disable that. And looping, disabled. Good. Let's go to our turret controller where we've just done quite a lot of things with the sounds. So private audio source. Audio source, and in start function I'm going to get that component to work with it alongside the rigid body that is used for the controlling of physics, and audio source play. So now we've just moved our code to the player instead of the bullet, and this would also allow us, for example, to decrement health. So maybe that is actually a more sensible place to put it, but this was a simple example. So let's just assign some kind of a sound to it. Oops. I've just added another audio clip there. Let's add it to the audio source. Okay. I remember. Well, let's try that. So every time the bullet hits the player now, we trigger a sound on the player. I'm kind of smelling a bug somewhere because at some stage you saw that we stopped getting the sound and actually the turret stopped hitting. Maybe that was just the distance, but right, I'll add the sound code. I'll push it later to the completed branch, so you can have a look at the sound code as well. So we've got 20 minutes to go. We haven't had a break for a while. Any questions? Any more questions?
Thanks.
Okay. Come again, sorry. Okay. Yeah, go ahead, please. Maybe we can do something more fun with this. It's live coding after all. Okay, so if not, then let's say we'll call it a day for today. Please DM me with your last name, and I will get you your lab test results in the next day or two. I can just type that so everybody sees. Cool. All right, I'll be online for a while. I'm starting next class at 1, so I'll give you a chance to get a breakdown. Thanks very much. Bye bye.